Alright, so today we're going to be talking about reference angle. This is section 3.1. Reference angle refers to the positive acute angle theta that is formed by the terminal side and the x-axis. Okay? The way we notate the reference angle is we're going to take theta. The reference angle is going to be theta hat. Okay, so it's going to look like a little caret over the top. Okay, it's important to remember that theta hat is going to be positive and acute. Okay, what does this look like? Here's what it looks like. If I draw in my x and y axis here, and I put in an angle, my reference angle is going to be this here, this angle that's formed. All right, and so, for example, this is going to be my theta hat for this angle in the first quadrant. Okay, let's look at this a little bit more in example 1. Example 1, we're going to name the reference angle. So watch how this works. I'm going to use 30 first. So what I'm going to do here is I'm going to start with drawing just some little coordinate planes. Okay, so I'm going to have 4 of them here. And then I'm going to put in these theta hats by drawing theta. Okay, so let's look at how this goes. If I'm going to do 30 degrees, then that's going to look like this. Okay, and so the 30 is going to go right here. Okay, so my theta hat is going to be this angle between the terminal side and my positive x-axis. So theta hat is going to equal 30 degrees. Okay, so that's kind of how this works. If we draw the next one, we've got 135. So I know that this opens up 90 here. And then this is going to give me 45 off this way. So my theta hat is going to be measured between the negative x-axis and my terminal side. So that's going to be this. And I know that this is going to be 45. Okay. So my reference angle is going to be theta hat equals 45. Okay, so my angle is 135. My reference angle, my theta hat, is going to be 45 degrees. Okay, so let's see how this works. If you want to go ahead and try the next 2 on your own, that would be great. If not, you can go ahead and watch me. So if I'm going to draw this 240, excuse me, I know that it's 180 over to this way, and then I'll go another 60. And so I know that this right here is going to be 60. So my theta hat is 60 degrees. You see how this works? And so we're making these angles small in order to help us make this skill easier. Okay? So for 330, let's look at how this goes. 90, 180, 270, and then we're going to go this way. And I know that this is going to be 30 less than all the way around. So there's going to be 30 degrees there. So my theta hat equals 30 degrees. Okay, and so this is going to help us by giving us a clearer picture of what this actually equals. And it makes our numbers smaller, which is always a bonus. Okay, so that's kind of how reference angle works. So in general, if theta is in quadrant 1, then theta hat is the same as theta. Okay, so that's what we've got for quadrant 1. Quadrant 2, theta hat is going to be 180 minus theta. Think about that because it's going to be above the x-axis over there. If we're in quadrant 3, theta hat is going to be equal to that, theta minus 180. And if we're in quadrant 4, it's going to be 360 minus theta. If we think back to our past example, when theta was equal to 330, that meant that our theta hat was equal to 30, or 360 minus our theta. Okay? And so this is kind of how this skill works. It helps us because now we can find the exact value of sine 40. When we're finding the exact value of sine 40, we're going to draw in our angle. And so I'm going to draw my coordinate plane here. And 240 is going to be 180 and then another 60. So I know that my angle here, go ahead and use blue, that's going to be 60. How does this help me? Watch what I do here. It's kind of special. I'm going to finish this triangle. Well, now I know that this is a 90-degree angle here, so this must be 30. I think some of you can see where this is going. Okay? If I've got a 30, 60, 90-degree right triangle, let's look at what happens. If I have a point on this graph, what I'm going to do is I'm going to say this will be -1 here. Okay? And so what happens is I'm going to say if 30 is across from -1, then my hypotenuse has got to be 2. Because we know that r is always positive and it's going to be twice the measure of the short leg. And so this is going to be -√3 because we're remembering our special right triangle, which looks something like this. And if this is 30 and this is 1, then this is going to be twice the short leg, and this is going to be √3. Okay, so this is sort of what it looks like. So now when I find sine of 240, that's silly. The sine of 240 is going to be equal to the sine of theta hat, which is 60 degrees. Well, we remember that sine is y over r. And so what I'm going to do is I'm just going to plug in my value. So my y is -√3. My r is 2. So this is my exact value for sine of 240. Okay? That's kind of how that works. It helps us because it's easier. I didn't necessarily need to know anything about 240, but I can use those special ratios for 60. Okay? Here's another example. Tangent of 315. If you want to try this one on your own, go for it. What I'm going to do is, once again, I'm going to draw in my theta to give me kind of an idea of what's going on. And so if I'm at 180, then I'm going to go 270, 270. So this 315 is going to be 45 less. So I know that my theta here is going to be 45. We'll complete the triangle. Pretty poorly, I'll admit. Okay, so we've got this 90-degree angle here. And what we're dealing with is, if this is a length of 1, we're going to assume that it's a length of 1, then we know that this is also 1. But it's got to be negative because it's below the x-axis, all right? And so if we've got 1 and -1, then this one has to be square root of 2 because the hypotenuse is the square root of 2 times one of the legs. Okay, and so when we're finding tangent of 315, it's really going to equal the tangent of, you guessed it, 45. Which means if my tangent is the ratio of y over x, then it's going to be equal to the opposite over the adjacent. So remember, this is theta here. Okay? And so it's going to be y over x. Okay? It's going to give us -1, which makes sense because we're in the fourth quadrant. So this is my answer. I didn't use a calculator. I didn't need to do anything else with 315. As soon as I found the reference angle, I was good to go as far as making that transition into saying what it was. Okay? Try this one on your own. I know we're going to have some problems with cosecant, but we need to remember that cosecant is equal to 1 over sine theta. I'm going to keep going. If you want to pause and try this one on your own, that would be a great idea. 300. I need to stick this out in the middle somewhere. So what I'm going to do is I'm going to say it's right here. And I know that this is going to be 60 then. Okay. I'm going to complete the triangle here. It's a tad bit lopsided. Okay. But we get the idea. Now, if I'm going to go ahead and say this triangle is out here and I'm using theta hat and this is 1, then I know that this is going to be, once again, 2, and this is going to be square root 3, and I know that it's going to be negative square root 3 because we're below the x-axis. And so when I find the sine of theta, it's going to be equal to the sine of theta hat. And I'm finding sine because I know that's what I'm going to need up here. Okay, so if that's equal to sine of theta hat, this is going to be y over r, and that's going to give me negative square root 3 over 2. And then I'm going to find the cosecant. So the cosecant theta is equal to cosecant theta hat is equal to 1 over, and here's where my sine theta comes in. I've got negative square root 3 over 2. And when I divide 1 by that, it's the same as saying, or when I divide 1 by that fraction, it's the same as multiplying by the reciprocal. So I'm going to have 2 over square root 3, and it's going to be negative because I've got this negative sign here. See how I did that? It's all fractions, people. It's all fractions. We're not worried about it. We're not sweating it because it's all fractions. Okay? So, the last little bit, we're going to recall coterminal angles. Coterminal angles, they differ from one another by multiples of 360 because when we're in the coordinate plane and we have a theta here, if I go all the way around, I come to another angle that's coterminal. They fall on the same terminal side. Okay? So, 360 plus k, 360 plus theta times k. Okay? They're all on the same, but they're just differing by 360 degrees. So let's find the exact value of cosine of 495. Well, 495, if I know that 360 all the way around is going to give me the same one, what if I went backwards 360? So I'm going to say 495 minus 360 because that's going to be 1 revolution. I know this is going to be 5, 3, 135. So instead of 495, I'm going to use 135. I'm going to draw it in using red once again. So I've got 90, and then this jets out at a 45-degree angle here. So I know my theta hat is 45 degrees. All right. So now we're just finding cosine of 45. If you want to, you could just draw a triangle here, which I am going to do as well. And I know if this is 1, and this is 1, this is going to be square root 2. Got to be negative because we're all in the second quadrant. Okay? Actually, that's not negative. You should have told me that because that's r. Okay? So now, cosine. Is x over r, which is negative 1. Worst square root ever. I know it. Okay? That's where we're at. We're using coterminal angles to make our lives easier. We're making our lives easier. Okay? So, that's it. That's all I've got for today. That's reference angle. Tomorrow we'll discuss it in class, but for now, that's all I got.